This video is for Lab 9, Digestive System. This is the overview of the makeup of digestive system. So it is composed of both the GI tract and the accessory digestive organs. So in the lecture where we have gone through all of them, I wouldn't spend time here, go through every single one of them again, but it is important for you to know which organ is part of the GI tract, which organ is considered as an accessory digestive organs. So this figure shows the generic makeup of the wall for the GI tract. So it is made out of 4 layers or 4 tunics. From the innermost layer, that's mucosa, is made out of the epithelium, lamina propria, and muscularis mucosa. And the second layer is called submucosa, and the third layer is muscularis. And there you have a inner smooth muscle layer as the circular layer, and the outer smooth muscle layer, that's the longitudinal layer. So which one is which out of those 2 layers, which one is the inner layer, which one is the outer layer, you need to know. Then the outermost layer for the outermost tunic for the GI tract wall, that will be serosa. Or it could be serosa when it's wrapped around by serous membrane is called serosa. If there's no serous membrane wrapping around it, then it's called adventitia. Let's start with the starting part of the GI tract. That will be oral cavity. So here is the anterior view, and you can see the outermost is the lips. You have the superior lip and the inferior lip. And then there are a few frenulum, right? So that's in the oral cavity. First one is the superior labial frenulum. So that's this cord connecting the lip with the gum. And then opposing that on the inferior side, there's inferior labial frenulum. There's a third one that's linking the tongue with the bottom of the oral cavity, and that's called lingual frenulum, right? Because then it's linking the tongue. It's related to the tongue. So that's why it's called lingual. And then the teeth we all know, right? Then we need to you need to be able to identify hard palate. So that's the bony part, right? On the top roof of the oral cavity, and then behind the hard palate, then there is the soft palate, and that's the non-bony part. Soft palate. And then behind the soft palate, you have this little protrusion that's called uvula. And if you look at the side view, the sagittal section, you see the hard palate here, right? That's because it's the one supported by a hard bone, by a bone, palatine bone. And then you have the soft palate here. There's no bone inside, and the uvula is the very end of it. So then you have the tongue here, right? So teeth, and gingiva is the term for the gum. That you need to get familiar with that too. So there are a few salivary glands too. You can see 2 of them here. So one is called sublingual again, that's deep under the tongue, and the other one is called submandibular salivary orifice, right? So that's right here, that's a little bit more anterior. It's the duct draining the saliva from submandibular salivary gland. Then on the sagittal section, you can see this the pharynx pretty well. So the most superior part is the nasal pharynx, and then the middle part right behind the oral cavity, that's oral pharynx, and then right here, right, the most inferior part of the pharynx is called laryngeal pharynx because it's just above the larynx. And then also on the side, you'll see the epiglottis. That's the top cartilage of the larynx right here. So when the larynx move up, this would actually close off the trachea, so to prevent things to food to get into your air passageway. You can also see the tonsils here, so be prepared, to be able to identify them on the models, even though it's technically we're not quizzing you guys on the lymphatic system because of the structure. The structures are here, so it's we may ask you about the tonsils here too. This diagram only shows the salivary glands. So you can see the biggest salivary gland is actually behind your cheek. So that's called parotid salivary glands and drained just by the parotid ducts into your mouth. And the two smaller salivary glands are both under your tongue. One is called sublingual salivary glands. You can see a bunch of ducts, right, drain the saliva into the oral cavity. And another one called submandibular salivary gland that's under the mandibular bone, and that has a longer duct, a single one that drains the saliva into the oral cavity. Now let's look at the structure of a tooth. So this is a molar tooth, and you can see all of the teeth are quite similar. It's made out of a crown, a neck, and a root. Right? So the neck and the root is buried in the gum, or the other term, gingiva. And so the hard materials of the tooth are enamel. So that's the one that's coating the top of your teeth. That's a really hard part. And then inside of the enamel, then you have dentin. And then inside of those hard, surface, then you have the soft area, that's called pulp. So pulp actually is in the cavity, right, of the pulp cavity. And what's inside of the pulp cavity are basically a lot of blood vessels as well as nerves. So here it's called the root canal, right? Because it's basically a bunch of the nerves and blood vessels together passing by this root canal and then linked to the blood vessels and nerves in the apical foramen. So let's look at the structure of a stomach. So here the stomach is made out of 4 major parts. The first part is called cardia, and the second cardia. That's just under the so it's the area right next to the esophagus. The next part is the top part of the stomach is called the fundus. And then the bulk of the stomach is called body, and the very tail of the stomach is called pylorus. So there's two sphincters, right, guarding the passage to the stomach. This sphincter here is right next to the pylorus, and it's called pyloric sphincter. And so what's unique about the muscularis of the stomach is instead of two layers of smooth muscle, it has a third layer that's called oblique layer, right? It's the innermost layer. And this is unique for stomach. All the other parts of the GI tract only have two layers, circular layer and longitudinal layer of the smooth muscles. So inside of the stomach, it also has this special structure called gastric folds. Another term for those folds are called gastric ruga. Let's look at the cross-section view of the stomach wall. You can see the four tunics that's made out of the GI tract, like mucosa, submucosa, muscularis, and serosa. Note the three layers of the smooth muscle inside of the muscularis. You can see the blood vessels mainly buried in the submucosal layer, blood vessels and the nerves. Strikingly, then you have the deep evacuation of the gastric lumen, and so it's called gastric pit. And what's inside of those pits are the gastric glands that's made out of 5 types of cells. And on your lab menu, page 4, you have the table of those 5 types of the cells, and you need to fill up that table with what's the function, what those cells secrete into the stomach. So that's going to be important for you to know. Here is a histology slide showing you the cross-section of the esophageal and stomach border. So you can see the border right here. This side of the tissue is the stomach. You can see the gastric pit, right? And you can see also the simple columnar epithelium right here is made out of the it's a kind of epithelium that's inside of the stomach. On the left side of the border, this is the stratified squamous epithelium that's made out of the esophagus. And so you can appreciate the dramatic, cross-cut, right, of the two kinds of epithelium that made out of those that lining up the GI tract in two different parts. Here is another histology slide from your textbook, and showing you just the stomach mucosa. You can see the gastric pit again. You can see those gastric glands can go quite deep, right? And they are made out of many different type of cells, right? 5 type of cells. And again, what are they and what do they secrete? What's their function is critical for you to know. So here is the list of the 5 types of cells I've been referring to. So the first type is the surface mucosa cell. So they are not only being found inside of the gastric pit, but they're also the ones lining up the surface, the lumen of the stomach. So they secrete alkaline fluid containing mucin, so to protect the epithelium from the acidic gastric juice. The second type is also a mucosa secreting cells called mucous neck cell. So they are closer to the lumen than the rest of the three types. And they secrete actually acidic fluid containing mucin. The third type are called parietal cell. So they are the cells that secreting the hydrochloric acid. That's the main acid that determines the gastric acidic pH. In addition to that, it also secretes intrinsic factor. So intrinsic factor is essential for for the vitamin B12 that's also required by our body to use that are used by our body to make red blood cells. So without B12, we can make red blood cells, and then we end up with anemia. So that is actually the that's the only essential function of the stomach. Is actually the ability of the stomach to secrete intrinsic factor, because no other cells in our body can do that. So those are the two functions for the parietal cell. And the next, going a little bit even deeper, that's the chief cell. And this type of cell secretes pepsinogen and gastric lipids. Those two both are digestive enzyme, but the pepsinogen is not active. So the reason you see this word ends with a OGEN, that means it's a precursor form of an enzyme. So when this pepsinogen is active, it becomes pepsin, and pepsin is a protein enzyme, proteinase, that chop up proteins. So those are two type of digestive enzymes. So lipids, what do you think lipids is going to do? Think about that. Okay. So the last type of the cell is G cell, and this G stands for gastrin. So gastrin is a type of hormone that's secreted by the stomach. So it is considered as enteroendocrine cell. Remember, entero meaning intestine, right? And then endocrine means hormone secreting cells. So basically, you can see the J cell are this type of cell is the closest, right, to the blood vessels. So that's kind of important for its function, right? Because the gastrin is not going to the stomach. Instead, it's going to the blood vessels. So this type of cell is closest to the blood vessels and furthest from the lumen of the stomach. So now let's move on to the small intestine. Here is a dissection of the small intestine wall, and you can see the same four tunics, and seems like nothing extraordinary about it. If you look closer, actually, the mucosa in the small intestine is quite unique. So the first thing, at this magnification, you'll probably notice the circular fold. When you zoom into one of those circular folds, and you can see a lot of finger-like structure called intestinal villi, and then you zoom into one of those intestinal villas. So this is what you see. Mucosa, submucosa, right? You see the lymphatic nodule buried in the lamina propria, and you see capillary networks going into each one of those villas. Not only the blood vessel capillary network, but also the lymphatic capillaries also going into each one of the villas. That's in those white color capillary, and they have a special name for the small intestine capillary lymphatic vessels. They're called lacteal because they are the primary capillaries that absorb lipid-rich nutrients and drain into the blood. So if you look at the epithelial cells, so they look like simple columnar epithelial cells, right? Nothing unique. No, actually, you can see the surface, the apical surface of those simple columnar epithelial cells. They're lined up with microvilli, and they do not have cilia, unlike this epithelium in the respiratory system, right? Here in the digestive tract, especially in the small intestine, they have microvilli. They also have goblet cells. Those are the cells that produce mucin. And it also have those investigations, just like in the stomach. And they are called intestinal gland. Or another word for that would be intestinal crypt. Okay? So you have gland cells here buried inside of those crypts and secrete either hormones, right, or some kind of peptides. So that's again a type of digestive enzyme. So in the page 4 of the lab manual exercise 7, you have also a table that you need to fill out. So here's a histology slide for the small intestine. You can see the intestinal villi here, right? And if you look at a microvilli, and you can see the microvilli here there's another name for it. It's called brushwater because under the microscope it looks like just like a paintbrush, right? So the hair on the paintbrush. And there are a lot of enzymes resides here, and that's where the digestion happens. Now let's look at the accessory digestive organs such as pancreas as well as gallbladder. And even though it's not showing here, the liver, it here already have the ducts from the liver, so the left and right hepatic ducts. So hepatic meaning liver. So those are the hepatic ducts that collecting bile that's secreted from liver, right? That's going to be converged into a common hepatic duct that's draining the bile from liver, and then some of that is going to be stored into the gallbladder, and so the bile can be concentrated and stored away. And this is gallbladder, so there's a duct between the gallbladder and the common hepatic duct. It's called cystic duct because it's connecting to the cyst, which is the gallbladder. And then where the cystic duct now is merged to form with the common hepatic ducts, then they merge together to form a common bile duct. And that is going to drain into the duodenum, which is the first part of the small intestine, through this structure that's called hepatopancreatic ampulla. Okay, we can understand why it's called hepato because it's from liver. But then how about the pancreatic part? because this is where not only the common bile duct drains into the small intestine, but also the main pancreatic duct drains into the duodenum. So therefore, this ampulla, so this, almost like a cavity, a cave part, is the place for two of those main ducts drain into the duodenum. So there's another pancreatic duct called accessory pancreatic duct that drains into the duodenum in a different place. This is called a minor duodenal papilla, and this is a major duodenal papilla. So let's have a look at the liver. So liver, this is the anterior view. You can see two lobes, right lobe and left lobe. Actually, liver has four lobes. So you can only see the other two lobes when you look from the posterior inferior view, because those other two lobes are smaller. So there's one on the anterior side called caudate lobe, and another one on the posterior side called caudate lobe. You can see the position of the gallbladder is towards the anterior. You can already see that poking out right from behind the liver, and that's what gallbladder looks like from anterior view. So the liver is actually made out of many lobules. See here, many lobules, and each lobule, in the middle of each lobule, has a central vein. So this is looking at one lobule. You can see a central vein in the middle, and then on the side of the lobule, you can see a portal triad. So each triad is made out of a bile duct, a hepatic portal vein, and a branch of the hepatic artery. So three things together called triad, called portal, specifically called portal triad. So we're going to talk about the specifics of it in the lecture. But between the peripheral of the lobule and the central vein, you can see the hepatic sinusoid. So those are a specific type of the capillary blood vessels, if you still remember, pretty leaky ones, right? So for the large intestine, let's first look at the big parts of the large intestine. So it starts with cecum. So that's the blind sac, and vermiform appendix is attached to the one end of the cecum, right? Here is the ileum, that's the last part of the small intestine. Ileum, last part of the small intestine, connect with the cecum through the ileocecal valve. And then you have the ascending colon, right? And then the transverse colon, and the descending colon, and the sigmoid colon because it's curved. And the last part is rectum, and before it ends at anal canal. And if you look at the colon, you can see those big kind of fragments of it, right? So each one of those fragments, enlarged fragment, is called rostrum. So rostrum is made of many of them, right? And what's unique about the large intestine is actually the muscularis, remember, is made up of two layers of smooth muscle. Inner layer is the circular smooth muscle, and the outer layer is the longitudinal one. For the large intestine, actually, they do not have a continuous longitudinal smooth muscle layer. Instead, you only have those comes into as in cords, and they are called Taenia coli. So it's almost like a string that the large intestine attached to. Let's look at the tunics of the large intestine. Still is made of the mucosa, submucosa, and muscularis, as well as serosa. But my question to you is, what's different here? Compare the large intestine with the small intestine. What do you think that's different between those two types of intestine? Okay, I'm going to give you a hint. You still see the intestinal glands, right? So those are the crypts or the pits. But you do not see is the circular fold or the villi or the microvilli. So instead, the mucosa is smooth, right? You do not have those additional structures that increase the surface area. So that's the major difference between the small intestine and the large intestine. Is the large intestine have a smooth mucosa. So this is the last structure for the GI tract. It's the rectum and anus. So rectum is a temporary storage place for the fecal matter before it's being eliminated from the body. So therefore you have those rectal valve to prevent the backflow of the fecal matter back to the large intestine. You also have those along the anal canal, you have those structures called anal columns, right? So those are protrusions, and the anus itself is controlled by two layers of sphincter called internal anal sphincter and external anal sphincter. So they are the smooth muscle that controls the elimination of fecal matter. And that's all. That's what all the structures we have for the GI tract and accessory organs.